So this video today is to answer the question, why would you care about the terminal? And then when you care, how exactly do you care? And the answer to the first question is actually pretty simple, because terminal is efficient. And when you code in C++, you can do a lot of things in terminal which are much easier to do in the terminal than in the GUI. And it might be a bit controversial for you now, but believe me, in a couple of months you're going to be a guru of terminal magic and you're going to feel so much better about it. The reason why terminal is so powerful is because it allows you the programmatic, well, to a degree, a programmatic interface to your system. And it all comes down to the Unix philosophy. What I can't do in the terminal, I can't do in the GUI. So for example, if I have thousands of photos in my folder and I would like to copy all of those that are named with a certain prefix, let's say a date and whatnot, I can easily do that from the terminal, and I don't even want to imagine how much time it would take me to do it from the graphical user interface. So that's the reason why you should care. Now, I mentioned Unix philosophy. Let's talk a little bit about what it is. And to talk about Unix philosophy, we have to start talking about what is Unix. And Unix is, well, it's kind of a family of operating systems that are overarchingly connected with these same goals. And the idea here is that a Unix system should provide a set of tools to work with the underlying operating system on which it runs. And these tools are usually a Unix file system, a set of pipes, which, so pipes is just a word that was invented to talk about communication between the different processes on your system. And finally, there is a Unix shell. So it's a kind of environment, think a program, that allows you to run other programs that can interface with your system. Let's talk a little bit about the concrete systems that you can run today that follow the Unix philosophy. And there is actually quite a bunch, but we are going to be focusing here on Linux and on macOS. So Linux is an open source operating system, the kernel for which was developed in 1991, if I'm not mistaken, by Linus Torvalds. And it is an extremely popular system. There is a good chance that you've touched this system already. So if you have an Android phone, well, that's it. You already run a Linux kernel in your pocket. If you ever used any platform that hosts on the servers, most of the servers run on Linux nowadays, as do the supercomputers for all the computation and scientific work that we are doing, and many more things. Like think embedded software, things that you run in the car or in an airplane and whatnot. All of those can potentially run Linux on them. So extremely popular system. And you can also run it on the desktop, of course, which is what I recommend you to do if you don't have any preference. If you never touched it before, just go with Ubuntu. If you have your own distribution that you like, just go with that one. Now that we talked about Linux, we also should talk about macOS. So in this course, I think I will mostly be using my Mac for all the live coding sessions and whatnot, but everything that I do here will be directly transmittable to the Linux environment. So don't worry if you don't own a Mac. And before we jump into writing code and into watching how it all works in the terminal, let's talk a little bit about how the file system is organized, because that's a bit different, especially if you come from the Windows world. On Windows system, you probably get used to having the drives that start with like a letter of alphabet, like C or D. There are none of those on Unix system. A Unix system always starts at the root, and the root is just depicted as a slash. So 1/ is the root of your system. Then there is a bunch of system folders under that and a bunch of user folders there too. As you can see on the slide now, there is a split into two parts, the system part and the user part. The system part is what the user cannot access directly, and the user part is basically a place where the user stores their data. If there is multiple users on the system, there's going to be more of those user folders. So for example, I would have a folder Igor under home if I'm on Linux, and under users if I'm on Mac OS. So again, this as a Linux example on the screen here, but for Mac OS, this actually looks very, very similar. And in a couple of minutes, you're going to know how to look it up for yourself if you've never done that before. Now let's talk about the left part of the slide here. Let's talk about the system part. You can see a bunch of folders here, and there is many, many more than those, but these are kind of important. These are the folders that will be on every Unix system out there. And let's start from the left. So if we look at this TMP folder, that's just a temporary folder. So whatever you do in that folder, and you can save files there and you can use it to store temporary data, but whenever you reboot your system, this folder will be automatically cleaned. So don't store anything that you want to use tomorrow in that folder if you turn off your PC today. Now, the opt folder is a folder where you can install software. So a lot of software that you download and install system-wide will be installed into this opt folder. And now we get to this USR, so user folder, not get confused with the user space on the right on the slide. And this user folder is actually a system folder where all of the binaries, libraries, and includes live. If includes doesn't tell you anything right now, don't worry, this is exactly why this course exists. We're going to talk about those, and we're going to understand why such a folder is needed on the system in the first place. So you can see the bin, the lib, and the include folder here. The bin holds all the binaries that you can run on your system. The lib has all the libraries that are required to run those binaries. And then there is this local folder. This local folder actually mimics the same structure underneath. So inside of that local folder, there is again include, bin, and lib folders. And the reason why there is this local thing is to make sure that whenever you install something locally on your system, you want to make sure that you cannot overwrite this by accident. So if you put it into the local folder, then anything that gets automatically updated knows that it should not touch that. So that's about it. And that's, I believe, all the necessary details that you need to know about the file system. And now we're going to dive a little bit deeper into how we can interact with such a system. And again, if you, if you're on Linux, you're going to see a picture that looks very similar to this. But if you're on macOS, then don't worry, it's going to be a little bit different, but all the main ideas are still exactly the same. So to run the terminal or to open the terminal, on Linux, you just have to press Ctrl-Alt-T. And if you are on macOS, then just open Spotlight and type in the terminal.app. All of those systems come with a terminal pre-installed. Again, this is a very, very important thing for any Unix-based system. And terminal is not just for programmers. It's an extremely powerful tool, and you can do a lot of really, really cool stuff with it. As I told you from the start, most tasks can actually be done much, much, much faster in the terminal than they can be done from the graphical user interface, and some tasks can only be done from the terminal and cannot be done from the graphical user interface at all. And what you have to remember about terminal is, remember we talked about Unix shells, and we've just talked about the Unix file system one slide before, but now is exactly the time to talk about the Unix shell and what it is. So whenever you open a terminal, that basically opens a new Unix shell. So it starts a program where you can run other programs to interact with your system. And there is actually a couple of implementations for a shell. So the most common ones used all over the place are bash and zsh. There's also fish, for example, but in this course, we're going to be mostly targeting bash and zsh. I'm going to be using zsh in the examples here, so don't worry if your terminal prompt looks a little bit different from mine. They're going to be behaving in a very similar way, and I'm going to provide a config so that you can set up your terminal to look exactly like mine. The only reason why I'm using ZSH is because now it comes standard on macOS, but well, actually that's not the only reason. ZSH has a little bit more customization points, so you can have you can tweak the look of your terminal to your liking much easier than you can with Bash. At this point, I think we can dive into how we can work with the Unix shell, and we'll start by talking about the variables. We can create variables in the Unix shell and then reuse them later. So to create a variable, we can use the word export. So if I type export and let's say I will call it, I don't know, something very important. And let's say it says just hello. So what you can see already here is a bunch of syntax. So first, export is the keyword that I use, or one of those programs that I can run. The blah is the name of my variable. The equal sign is just part of the syntax that the shell uses to set up this variable. And then in the quotes, you can see hello, which is just a string. So a string can be represented in the normal double quotes or in single quotes, and we're going to be talking about what is the difference between those in just a little bit. So when we press enter, this command gets executed, and now blah has a value, and now you probably have a question on how can we get the value from it. And for that, we will use another program which is called echo. And echo is actually pretty simple. So if we type hello world after the echo, then it will just print hello world. So what it does, it just prints things that you pass to it into the terminal. But it doesn't do just that. So if we now type not just echo hello world, but we use our variable blah, and let's do the world here, it actually prints the same hello world because in the blah a word hello is stored right now. So I hope that shows how to set up and how to use the variables. And by the way, you can also omit the curly brackets, but a better style is to always use curly brackets with your variables, because that helps you avoid any possible errors with the syntax. One more cautious thing to think about here is if you are using the double quotes, then your variables will be expanded. But if you don't use double quotes and use the single quotes, then they will not be expanded automatically. And what you will get is you will just get the verbatim string that you put in. So keep that in mind for the future. An important understanding here is that a Unix shell is always in some state. So when we talk about the state of the Unix shell, we're talking about a folder from which we run all of our commands. And that folder can be queried with the command pwd. And you can see now that I'm now in the temporary folder in the cpp for yourself folder within the temporary folder. We can also change this directory by calling the cd, and for that we just pass in the directory to which we want to change, and let's say I would like to change to the tmp directory. So now I am in the tmp directory, and if I want to go back, I can again type the the old name that I used before. Typing all these paths can be a bit daunting, so there is a mechanism to help you avoid typing these paths. And whenever I want to navigate to a certain folder, I can just easily type cd. Let's say I want to go to tmp, and let's say I want to go to my cpp for yourself course. And whenever I press tab, if there is the only option available, then it's just gonna complete this for me. So that's nice. But if I want to go somewhere and there is not a single option out there, then tab will show me all the different options that can be used instead. So if I keep pressing tab, it will cycle through those on ZSH, and on bash it's gonna be a little bit of a worse interface, but essentially it's gonna do the same thing. Great. Let's talk now again a little bit more about the variables that we've just touched upon. We can define, of course, our own variables, but there is a bunch of variables that are already available on the system. So if I type echo hello, and then I would want to use the variable user, then I'm going to be getting a hello Igor as an output, because a user is a predefined variable, and it gets populated with the name of the user currently logged in the system. And on this system, it's me and my name is Igor. So everything checks out. There is a bunch of other variables that are very useful. For example, if we print the home variable, it will print the home directory of my user, where all of my documents and photos and whatnot lives. And that is exactly the same place as you've seen on the slide before. Under the home directory on Linux, it's under users on macOS. Another important variable here is the pwd. So again, this one gets populated to the current working directory, and this is exactly the same as calling pwd command that we've seen before. And finally, last but not least, a very, very important variable is the path variable. So the path variable holds all of the paths where the shell is going to be looking for the commands. And there is a lot on the screen now, but don't get scared. It's all fine. It's just a lot of different paths that are split with a colon. And whenever we type in a command, we will, so the shell will actually look in all those folders, and if it doesn't find a command there, it won't be able to run it unless it's available in the local directory. So that should be that. So now you've seen a bunch of paths at this point. And by the way, to clean your terminal, you can always press Ctrl-L, and this will clean all the output that you don't need anymore. So we've seen a bunch of folders now, and we should probably talk about those again. So in Unix, it's actually pretty simple. So all the paths start with a slash, represent absolute paths, so the ones that start from the root directly, and all the other paths that do not start with a slash are actually relative to the current working directory. Another important thing to note, especially if you come from Windows, is that a file extension is part of the file name. So I think on Windows, you cannot have two files with different extensions but the same name. Here you can easily do that, and we're going to see that in a second. Let's talk about commands a little bit more. So every command in Unix has the same structure. It starts with either a full path to the command or just the name of the command. Then you can provide some options and some parameters to it. Every command, when run, returns an error code, and if it returns a 0, it means that everything went well, and if it does not return a 0, it means that something went wrong during the execution of this command. So that seems to be pretty easy. And every command can accept some options and can accept some parameters, and there is no way to know which options and parameters this command accepts, so this has to be documented. The way we document those things is either through a manual or through giving the -h or --help flag by mostly a convention. I don't think that's any rule or something like that. So let's see how that all works. We already used a bunch of commands out there, so let's actually see how, let's say, echo works. And for that, let's type man, which stands for manual, echo. And you can see there is quite a significant amount of documentation here on how to use this piece of software. To exit such a manual page, you just have to press Q. So most of the system tools actually provide such a manual, but if you have an external tool, then usually it provides something like a help. And just for an example's sake, if I type Sublime text, or subl command starts the Sublime text editor, and I press and I pass a -- help option into it, then I get a view of what I can and what I cannot provide to it. So it tells me what is this program, how to use it, how to use arguments, which parameters to provide to it, and so on and so forth. When I press the -- help, I do not actually need to provide anything else, like any parameters and whatnot. Right, so now that we know how to move around our file system and do different tasks and run the commands and define variables and use the variables, let's talk about how can we create the files, how can we modify content on our system. And for that, there are more commands that we can use. Let's start with a touch command. So if you type, so I'm again in the same folder, in this temp cpp for yourself folder. If I do a touch, let's say test.txt file, then I can now see this text file here. How can I see this text file here is with the ls command or the list command. So if I just type ls, then it shows me the content of this folder right here. And I can of course create more than one file, and let's say I create the test cpp file. And now if I do ls, I can see both of them. ls also takes a bunch of options. So a good set of options to use with ls, if you want to see all the information about all the different files on your system, is the -lah, which is actually 3 different options combined together into one. So let's try that. So let's type ls -lah, and what you see here is a full information about the contents in this folder. On the left, you can see the access rights to every single file. Then you can see who owns those files, then the size of those files, when they were modified or created, and then the actual files. And you might notice that in addition to the test cpp and the text txt file that we've just created, which are empty, there are 2 more entries here, the dot and the double dot. So these are actually predefined names that are common to any Unix system. And these names hold the current folder, so the single dot is always the current folder, and the double dot is always the folder one above. So just to illustrate this, whenever we type ls, we can actually provide also either a folder name or a file name. So if I type ls test.txt, it will just show me this test.txt file right here. But I can also do the same and just type ./test.txt, which is exactly the same file. So it's still in this folder, and that's that. We can also do the same, but with the double dot, and then we can also have the cpp for yourself folder in there. So we go one folder up, we go back into this folder and see this test.txt file, and you can see that that still works. In case I type a file that does not exist here, then it will complain that there is no such file or directory, so it can't show it to me. Right, so I hope that's all clear, and we can actually move on to creating folders. For that, there is a command which is called make directory or mkdir. And let's say we create a folder named folder. So now if we do the ls, we can see a folder. It's usually written in a different color so that it looks a little bit nicer, as well as the 2 files that we have here. We can also create folders within folders. So let's say I would like to create a folder inside of my folder. So folder, then I would like folder 1, for example, and that works too. So now if I ls the contents of the folder, I can provide ls with a parameter of the folder I want to show, and it will show me it will list the contents of that folder that I provided to it. And now, of course, we can see the folder one being right there. But if I want to create a deep hierarchy straight away, so I would like to create a mkdir folder deep, and then another folder within that folder. Then I can't do that directly because it just won't let me in case I actually am doing a mistake. But if I provide a -p flag, it will actually do that for me. So now if I ls the folder deep, then I can see another folder in my deep folder down there. So that's all great. If I don't like some file for some reason, I can of course remove it. Let me just clean the screen so that it's again from the top. So I can remove, let's say, test.txt. Let's say I don't care about the txt files anymore. And now if I ls, I won't see this file anymore. If I want to remove the folder, I cannot just type remove the folder, because it says it's a directory, so I actually have to provide an option, the -r option, and the -r stands here for recursive. So it means that it will go into this folder and it will remove all the other folders that it finds within this. And beware, this is a dangerous command. It's a destructive command, so it doesn't copy it into any type of bin or anything like that. Like a trash can or something. It just removes the files completely. So once this command runs, you can still probably recover the files with some specialized software, but it's nowhere on your system. It's not stored anywhere on your system. Once you run rm command, the files are lost. So at this point, I don't care about the folder, so I can easily just remove it. And now you can see that it disappeared from the output of my ls command. Now, if I would like to copy the contents of a certain folder into a new place, I can easily do that with the copy, and I can also do that with files. So let's say I want to copy my file first, and I want to copy it into the test copy cpp. So the way the copy command works is it copies from a certain file to a certain file. And if we run this command, we now have the test and the test copy, which is the exact copy of the original test file. We can do the same with the folders, but then we also need to provide the -r flag. So if we try to just copy the folder deep into a folder copy, it says it cannot copy because it's a directory, but we can provide the -r flag, and now it gets copied. And so now both the folder copy and the folder deep have the another folder in them. So that's exactly what we wanted. If we want to move a certain folder somewhere, we can do that in exactly the same way. So if I want to move a folder, let's say I want to move a folder deep, and I want to move it to folder. So this, in this case, will just rename the folder. So it's a little bit of a quirk of the move command, but once you get used to it, it makes sense. So if I run this command, then now I only have the folder, and folder actually has the content of the folder deep. But I can also move the folder now into the, say, folder copy. So if I want to move the folder into the folder copy, I can do that, and I just have to end it with a slash just to be sure. And now if I ls the contents of the folder copy, then I see my folder that I just moved there, as well as the another folder that was already there before my move. So that should be it on these type of commands. I can also use placeholders. Whenever I do any of those actions, this is the example that I provided you with before. So if I have a ton of files, I have really many files in my in my folder, and I would like to take all the text files from them. That is a bit of a complicated task if you are in the graphical user interface, but I can definitely do that here. So let's say, I mean, now the contents are like this. So let's say I will create another text.txt file, and then maybe test.txt file. So let's create a folder for the txt files, and let's create a folder for cpp files. And now I would like to copy. So let me just show what the contents of the folder right now are. So I have a bunch of folders, and I have a bunch of files here. And now let's say I would like to copy all of my txt files into the txt folder. So, and you can see that I use the star here, which is one of those placeholders. And these placeholders are really, really useful because they can replace any character on the in the pass. So let's say for now I do this, and now if I just list the files in the txt folder, I can see that all the txt files are actually there. So that worked pretty well. But let's say I would like to be a little bit more specific. So now I want to copy everything that looks either like test or text, but I don't want the test copy. And for now I will just use the ls command because I can actually do exactly the same things. So if I ls star txt, I will just show all the txt files, and if I do the same with the cpp, I will just show the cpp files. So let's say now I would like to copy any file with any extension, or actually list any file with any extension, and I wanted to start with t or te. Then I would like it to have either an s or an x, and then I would like it to end with t, and I want it to have any extension, I don't care which one. And if I do that, then I get all the files which conform to this. And I've used another pattern here. The square brackets, they basically have a list of the characters that I want. And if any character, if the character on this spot matches any of those characters in the square brackets, then this particular file matches this pattern. And if I want, I can also negate that pattern. Right, there is a bunch of other important symbols that are important to know. So if you want to navigate to your home directory, you can always just type in tilde, and tilde actually navigates you to the home directory. So now if I ls in this directory, I can see all my documents, code, and whatnot, the other files that I have in my home folder, but for now I will navigate back to my temporary folder in which we work here. So tilde is used like that on both Linux and macOS, and it works in exactly the same way. So now that we talked about how to run the commands and how to navigate the tree of our system, I think it's a good time to talk how can we chain the commands together. And before we do that, we have to talk about what ways of putting stuff in and out of our commands exist in our Unix shell. And generally speaking, there is a notion of input and output channels. There is a single input channel. It's called a standard input channel, or the one that is usually used. And that's when you type something into the terminal, that's the channel that you are using. And the commands can ask for input from this channel. They will ask for your input that you have to provide, and then they will read this input from this input channel to use inside of those. And whenever the programs output to the outside, they output through either of the two channels, the standard output and the standard error channels. There can be more channels than that, but these are the standards one. Usually the std out, the standard output channel, is the channel number 1, and std-err, the standard error channel, is the channel number 2. Right, so how can we use that? So let's say I would like to, again, I'm in the same folder, I still have all those information. So if I would like to store that, then I can just forward the, so whenever I run ls, it actually prints on the terminal. And when it prints on the terminal, that means that it just puts the information that it generated onto the stdout stream. So now what we can do with the stdout stream is we can provide this stdout stream as an stdin stream for something else. And we can, for example, pipe it into a file. So let's do just that. Let's call the file ls.txt. And now we've just put stuff into that file. We can also see the contents of that file. So we can take the contents of the file and put them on the stdout with the command that is called cut. And let's do just that. So if we now cut this command, then you can see the output of the ls exactly as it is on our screen, but we've put it in the file, and now we read this file from the file and put it on the stdout. If there are any error messages that happen during the execution of a certain command, usually those are printed on the std error channel. Cool. So if we want to append something to this, let's say I would like to type echo hello world, and I would like to write it into my file after all my after the ls output. So before I used this greater than sign, but if I use that, it will overwrite the file. But if I don't want to overwrite, I just use two of those, and I can now write it to the test.txt. And again, we can cut this file, and you can see that hello world is right below there. This way, like, we just redirect the stdout or studout channel, but we can redirect either both or just one of them. To redirect both channels, we can do that quite easily. Let's do again our example with ls. So we take the ls, we move it, we redirect the output to the ls.txt, and now what we want to say is we want to say that the second channel should go onto the first channel. So now if ls actually prints an error, then we will get it there. So I mean, ls does not print any errors, but let's do something that does. So let's try to copy a non-existing file, blah blah. Let's copy it to folder. So if we try to do that, it will print an error, and this error is probably going to be on the stdr. And we can actually check that by trying to just pipe the output into the copy.txt. And you can still see that we got the information on our screen. So that means that we piped all the stdout into the copy.txt, which was empty, and it's still empty because there was no stdout output from there, but there was stdr output, which we did not pipe. So now let's try to do the trick that we did above, and now we're saying that pipe the std error output into the stdout output and put that stdout output into the file. So now we run this and we see nothing on the screen, which is exactly what we wanted, because we can see that that the content of the copy.txt now holds our error. And we can also do that separately, so we can we don't have to pipe them together, we can pipe them separately. So let's say I would like to pipe my stdout copy.txt to stdout, so stdout to stdout copy.txt, and I would like to pipe my stdr to my stdr copy.txt. So you see nothing happening, and if we now look at the cut of those, so the stdout copy.txt is empty because copy did not provide anything for us to actually see there. But if we cut the stdr copy.txt, then we see that the error was actually stored in that file. And with that, that's all the information that you have to know about these type of things. There are definitely more tools than we've covered right now, but these are the most essential ones. And if you know these ones well enough, then you should be good on your journey to learn terminal. Finally, there is a bunch of more tools that are very important in our work. So there is a find tool. So if I want to find a certain file in a folder or certain files in a folder, I can easily do that. So I can type find, and let's say I want to find them in the folder copy. No, actually I want to find them in the txt, for example, copy, and I want to find the file name test.txt. So what it will do is it will show me this file, and I can do that for arbitrary types of files, and I can also use the wildcards there with maybe providing another option into the file find command. And one of my favorite commands out there is the grep command. So if I would like to look for a certain string in a certain file, I can easily do that. So let's do just that. Let's try to grep for the txt in the files ls.txt. And you can see that now it's printed the contents of the files, of the file that we provided, but not the full content of that file. It just provided all of the lines in that file that contain the text that we want. And that is a very helpful tool to look at the output of a certain command and see if there was something relevant to us there. Great. So now finally, I think the last thing that we have to cover in this topic before we can jump into the actual C++ coding is how to chain those commands. So if I want to chain a couple of commands, I can easily do that by just separating them with a semicolon. So let's say if I want to say hello and I want to say hello and I want to echo world, I can just chain those together and it will print hello and world afterwards. And this way the commands don't really wait for the execution of each other. I mean, they do wait, but they don't expect that the previous command has to necessarily actually succeed. So if the first command does not succeed for whatever reason, the second command still runs. So I can illustrate this with, again, copy of our non-existent file and then doing the echo hello world. So you can still see that we had an error in our copy because we forgot the other file at all, and we still can print the hello world. Now, if I don't want that, if I want the second command to only be run if the first one succeeds, then I can connect them with the AND operator, and then the second command will not run if the first one does not succeed. But in the case it does succeed, we still get our output from both commands. You can also pipe the outputs from one command to another, and that is done with the pipe symbol. The pipe symbol is just a vertical line. That is a very extremely powerful tool. Like, you should definitely have it in your toolbox, and let me just show how it works. So let's say I would like to ls all the files here, or actually I would like to cut the contents of the ls.txt that we did before. But now what I can do is I can provide the output from cut. So the cut command just takes the information from the file, puts it as the std out onto our stream, and then takes this stream and puts it on the screen. But what we do with the piping is we take that stream and we put it into an std in of the next command. In this particular case, it's grep, and that's the usual case. So usually you take some command and you pass it into the grep command. And now let's say I would like to look for any anything that has CPP in it in that output. So if I do that, then I can see the output from here. Of course, I could just use grep directly on the file, but I don't always have the file for that. It's just in this particular case that I use the cat command. But if I would do like the ls, like all the files here, and I would like to grep for CPP, then that would work too. And it would also work if I have the long output from here. So you can see that these lines are only picked that have the string that I would like to look for, and that is an extremely helpful thing to have. Cool. And finally, you've already seen me doing this a while in this tutorial here, but I want to explicitly state it. You can kill any command with Ctrl+C. You can, if it doesn't, so actually it's not a kill, it's an interrupt, so you can send a request to the command to interrupt, and not all commands respect that request. So you can actually kill them forcibly, and that's done with Ctrl pipe. So again, pipe is this vertical line symbol that we've talked about before. If you pass that, then usually the commands die really quickly. You can also, if you know the process ID of your command, then you can kill that command with the kill -9. Again, it's sending a kill signal there. Or you can kill all processes with a certain name. To be honest, this is rarely used, and if I need to kill something, I'd rather use the htop command, which is one of my favorite commands on the terminal at all. It shows it shows you the system load that you have, the memory that you're using and whatnot, and you can also navigate here on all the different processes that are run on your system, and if you want to kill one of those, you can easily do that by just pressing F9. Great. Finally, you've again seen me doing this before, so if I just press the arrow up, it will cycle the, actually let me clean the screen, it will cycle the history of the commands that I used before. So that's very useful. If you press Ctrl R, then you can actually see this history of the commands if you're using FZF, which is a very handy tool, and I will show how to install it probably in the description of this video. But if you don't have the FZF, you can just search in your history directly by just typing the commands that you used before. This is extremely useful. You can also just see the whole history in your home directory, and it's in the shell that you're using. So in my case, it's ZSH. It might be bash history in your case. And if I just look at all those, you can see the list of all the commands that I've executed here at all. The final thing that I would like to talk about is how to install software on your system, and that is different depending on the system. If you are on Linux, then a lot of software is actually available through the package manager, and you can just install it on Ubuntu, for example, with apt-get, and on different other distributions with their own respective distribution management system. But if you're on Mac OS, you might need to download the DMG image and then put it into your applications folder. Or you could install Brew, which is kind of a very similarly looking thing to the package distribution on Linux, although it works a little bit differently, but it behaves in the same way, and then you can just type brew install whatever you want to install. I really like that tool. It works really well for me. In case you will need something for the course, I will always try to have a video on how you can install it on Linux or on Mac, so that you don't get lost in this. And with that, I think you're actually now well equipped to start your journey into C++, because now you know how to run different commands, and you will see how that is relevant in one of the next videos. Thanks a lot for watching, and see you next time. Bye.